Hi folks, I'm Chuck Black. We are doing Quokka walkthroughs and we are in walkthrough number 13. In this video lesson, we're going to talk about remote workers. Remote workers are the things that provide the functionality that give us this nice traceroute output, extended port scans, packet capture, things of that nature. They're called remote workers because they can run remotely on a different system and because they perform work for us, and the work that they perform requires them to be running in super user mode, so they need to be external from the Quokka system. They can be initiated, all of these exercises of getting packet capture, port scan, traceroute can be initiated via heartbeat commands that come back when we do a heartbeat from the worker. They can also be initiated by RabbitMQ, the messaging system, and that works across different systems as well. So that is what we'll talk about. We'll look at the architecture, we will look at the code. We won't go into a ton of minutia about all of the different workings of these workers. Maybe I'll do a second lesson to look more at them, but we definitely will look at how the code is designed, how we have a Quokka worker which gets run by the run workers and parameters are passed, and we have a worker thread that gets created that does things like heartbeat, as well as invoking the individual processes or the individual process of doing packet capture, port scan, traceroute, etc. by sending messages to the workers that are remote, and they will perform the task. When they're done performing the task, they will send the information back. It gets stored in the database, and then the user interface is able to retrieve it and print and display nice messages like you see here with traceroute. So that's what we're going to be going over. It covers a number of different things, including threading. These workers do things like with scapy, with nmap. We have RabbitMQ to do messaging. We have REST APIs, and we have database stuff. So all of these get touched on a little bit as we begin to understand how this works. So hopefully it will make sense to you and you will learn something from it. So without further ado, let's get started. Okay, so we're going to talk about remote workers and how they do what they do. Now, before we get into that, maybe you don't know exactly what remote workers are. So I'm going to start by demonstrating the functionality that they bring to Quokka. So we're going to look at my list of devices, my list of hosts, and my list of services. Over here on the left, I have these action buttons, and they each do something different. This one gives me status. This one does a packet capture. If I was to click on this packet capture, it will show me the packets that have been captured for that device. Now, the reason that there are packets in here and that I can look at them is because I have previously done a packet capture. You can see that this is saying that it's today at 10:12, and I can tell you, in fact, if you look at the very tip top of this screen, it's 10:25. So what I'm going to do is I'm going to go ahead and start to do a capture for packets that are destined for that device. Now, I should let you know I'm running Quokka not on my local host. My little laptop here has 16 gig of RAM, but it's 5 years old, and it's also doing Camtasia recording and a bunch of other stuff. So it's pretty busy, and it has this VM in which I'm demonstrating stuff. So there's a lot of stuff going on here. Therefore, I'm running Quokka on another laptop that I just flashed an Ubuntu system onto it, and it's running Ubuntu all by itself. And so it is actually collecting packets for me right now. I can see that it is, and it turns out that I didn't actually pick up any right now. Let me refresh the packets. There you can see that the time is 10:26. Now that's actually coming from the other system, but fortunately the time is consistent between that system and this one. And you can see I have these packets. How did I get the packets? Well, because I have a remote worker that's actually doing all the packet capturing for me. Now, what else was I going to demonstrate? Packet capture was one thing. If I were to go to hosts, I can do a packet capture also, but one of the things I can do is an extended port scan. So I'm going to go ahead and click on this. You'll have to take my word for it. I'm looking at my other laptop and I'm watching it do the port scan on this device, and it has given me the information on my port scan on this. What is this? I think it's an Amazon device that is in my home. And so this is an extended port scan. And once again, similar stuff is happening over here. This picture only shows packet capture, but similar things are happening. And then lastly, I'm going to go to services because that's where traceroute gets interesting. I'm going to click on this action button, and this is going to invoke my remote worker, and the remote worker is going to go and it's going to use Scapy to get the trace route and to create a picture of it. And I'm actually sending the picture back into my own database on my Quokka machine, and then that gets forwarded out to the user interface so that I can look at it here. So that's what we're talking about when we're talking about these things that I call remote workers. So before we go too far, let's look a little bit at the architecture of how these things work. So what you're looking at here in this picture, which is from the wiki, by the way, so you can go out and read this anytime and read the words that go along with it. This is the general architecture for how these remote workers, for lack of a better name, I just call them remote workers, work. Now, it didn't always work like this. They didn't used to be remote, and in addition to that, they weren't initially planned to be external to the Quokka system itself. Let me give you a little bit of the evolution of how this all transpired. Initially, I had created some Quokka functionality, mainly around devices, and talking with my friend David Bombal, he said, it would be cool if you could do packet capture. And so I said, that sounds like a good idea. Why don't I see about doing that? So I started to implement packet capture, and I was going to use either PyShark or Scapy in order to do that. And both of those, as you probably know, require super user or root access. Now, the Quokka system is actually a web service system, right? It's running inside Flask. And in general, it is very, very strongly discouraged that you run Flask in super user mode. And the reason for that is for security, because as you know, web services typically face the outside world. The outside world is full of bad actors, and these bad actors are constantly trying to find ways to get your web server to execute something that it shouldn't. And if your web server has super user privileges, then that's a really, really, really bad thing. And consequently, I said, okay, just starting on the capture worker, what if I just write a little application that runs in super user mode and takes requests and captures packets? So this was the initial genesis of what we now call remote workers. And I needed to create a mechanism for communication between the Quokka system and my little capture application that was running. And so because I wanted to teach you guys as much as I could, I decided to use RabbitMQ as the means of passing requests out to this worker. RabbitMQ is a messaging service that allows you to pass messages, and anybody who subscribes to particular types of messages can receive them, pull them off the queue as it were, and then perform whatever function that message requested. Now, for returning the data, as you see up here, I'm using HTTP to return the data. Could I have used RabbitMQ to return the data? Yes, I could have. However, I decided for, again, teaching purposes, that it would be useful to show a worker communicating with the Quokka service and sending the data back. So packet captures, I decided to send back using REST APIs. And as we've looked at the code, you've seen that there are UI REST APIs, but there's also a bunch of these other REST APIs for communication with capture workers and port scan workers, etc. And so that's how I decided to do the architecture. These specific applications each do their own thing, and so the capture worker will run the packet capture process. Whether that's scapy, it will invoke scapy, or it could invoke PyShark. It doesn't really matter. The Quokka system doesn't care about those nitty-gritty details. It will use whatever it wants. Port scan, I decided to use nmap because that was pretty simple and straightforward, and it was a different tool for me to experiment with and that I could teach you guys. Traceroute, scapy has a very nice functionality to provide that. Not only that, but it also provides the graph as we looked at. So yeah, that's how these ended up being what they are. Now there are two different ways of this here, this line that you see here, communication from the Quokka server out to the worker. There's two ways that we have this work. One is the simpler way that I initially did it, which is using RabbitMQ. But once we cottoned onto the idea of allowing these to be remote and the value of that, it occurred to me that if we were running this somewhere like at an SD-WAN site or something like that, where the site is truly remote and there's a firewall between the Quokka server and these workers, maybe in a remote office or something like that, then I may not be able to do RabbitMQ from the Quokka server down to these devices because that port that is typically used won't necessarily be open. And so we said, well, is there another way to do that? And I've actually worked on this at my TLAC work, and this is a way to do it. And basically that is, these workers are constantly sending heartbeat messages to let Quokka know that they're alive. You see the results of that up here. If I look at the workers on my system, I see I have 3 local workers on my, remember this is on my remote system. I see that those are up and running. I don't have the workers running on my other laptop, and so those aren't up right now. But I know that their status is okay, and I know when they were last, this should say last heard actually, because I didn't actually check them. I think I changed that in the code, but apparently I didn't change it in the user interface. This should say last heard. It was last heard at 10:38. Right now it's about 10:39. So about every minute, I think every 20 seconds or so, I'm getting a heartbeat from these workers. And here's what happens in this other situation. In this other situation, we've gotten rid of RabbitMQ. And what ends up happening is these workers are constantly sending heartbeats. I don't have a line that shows the heartbeat, or maybe I do. Yeah, this is the heartbeat here. You can see the arrow is bidirectional. It's going in both ways. So the workers, where each of them individually will go to the Quokka server and say, hey, here's my heartbeat, I'm alive. As you can see, it will also report a couple of health things like CPU utilization and memory utilization. You would expect these all to be the same since they're running on the same system, that other laptop. So I do the heartbeat and give that information, and I also say, hey, by the way, do you have any commands for me to execute? So in this situation with RabbitMQ, the user says, I want you to do a traceroute, and we immediately go out and tell the appropriate worker, hey, go do a traceroute. In this situation, what happens is the user says, hey, I want to do a traceroute. So the user interface is going to say, oh, I need to put a traceroute request into the commands database. And the next time the traceroute worker makes a request via heartbeat, it's going to say, do you have any commands for me? And as you might imagine, what's going to happen is we're going to look in the database, we're going to retrieve any commands, we're going to mark those commands as having been delivered, and then we're going to go off and do those. And in both of these situations, the data that is captured, either the packet capture or the port scan or the traceroute, in both of these situations, the packet data is, I mean, the data from whatever it was, packet capture, port scan, or traceroute, that data is going to be sent to the Quokka server via this REST API. And as you can see, I have database tables that are holding this data. And therefore, when the user interface is waiting for data to come back, it is going to end up having the Quokka server query these databases, and it will give it the appropriate information. That's how, when you're here and you're like, let's say, services, and you want to say, give me the trace route for this open DNS servers, what's going to happen is the request is going to get made, and that data is going to get put into, what am I doing here, traceroute? It will get put here in traceroute results, and the user interface is going to come and grab that data and pass it back to the browser. And that's how we end up with this information. And this is true not only for traceroute, but it's true for port scan. We were looking at port scans for the hosts. Let me choose something different. I am going to use this particular device and do an extended port scan. Sometimes port scans can take a while, as I warned. But this one didn't. This did the port scan. So now you know what ended up happening. Now I'm using RabbitMQ. I'm going to close this, and we're going to look at the workers, and you're going to see my connection type for my local workers on the system I'm running this is using RabbitMQ, and consequently, this is what happened. Now the upper part is the same no matter what, but RabbitMQ sent a message to the appropriate worker, which was running on localhost. As you can see from this picture, these are running on localhost, and the request got sent. The job was done using whatever tool I used, and the data was sent back into the database, and the user interface grabbed that at the appropriate moment. So hopefully that's making some amount of sense. There's a fair amount of stuff going on, but I don't know if you'll agree with me, but I think this is really cool just because there's so many moving parts. There's so much interesting Python and software functionality going on. This is probably my favorite part of the whole Quokka project because of all this stuff that we're getting to do. We've got we've got the user interface, we've got RabbitMQ to make the request, we've got remote workers that are doing their thing, we've got requests coming back via REST API, they're getting stored in the database. Oh, and what we're going to be getting into is that this is all developed in sort of an object-oriented manner, so you'll get a chance to get some ideas about inheritance and things of that nature when we look at the code. So hopefully that hasn't blown you away too much and it makes sense. And yeah, next let's look at the code and see how that actually works. Okay, so hold on to your seat because we're going to look at the code now for our workers. Now the first thing that I want you to notice is that I've actually moved things around here. Workers used to be underneath Quokka, and the same is true for SD-WAN SIM. I noticed that, and so what I did was I refactored by moving this folder out of Quokka so that it is now a peer of Quokka. That kind of makes sense just because of the fact that in our picture they exist separately. They don't exist within the Quokka server system. So now they live external to it, and that's one thing that I've done. Of course, I had to change run workers to point to the correct spot. I haven't checked this in yet. I am on my main branch, so the next time I push to main, then these changes will be out there. Hopefully that won't cause you guys any problems. The other thing I did is there was a number of files in here that I no longer needed, so I got rid of them. So this is down to the bare minimum of the files that we had. And the third thing that I want to point out just looking at these files is this. Quokka worker is the main thing that we run. For example, when we actually do run workers, what we are actually calling and running from the command line with Python is quokka_worker. So quokka_worker is the main program or Python application that we run. From that point, and let me just wave my hands and explain this and try to let it be absorbed into your brain. We start a thread called worker thread. Now, this is a generic thread that every worker that exists will have running kind of on top of it. So there's this worker thread that sits there all the time. It gives the heartbeats, etc. And then there are these on-demand threads. Capture, port scan, and traceroute are all on demand. So they get launched, they do their thing, and then they go away. Worker thread sticks around forever. And kind of the parent of the whole worker thread is quokka worker. So it runs, it starts up worker thread and then sits there. And then worker thread also sits there. And then these three things are transient. Capture, port scan, and traceroute get created to perform their task. And then they go away. Okay, hopefully that makes a little bit of sense. I wanted to give you that overview before we actually dive into the code. I think that I would benefit from having a picture, or maybe everybody else would benefit from having a picture of this, and I may do that, but I wanted to continue with today's lesson. So if you say, Chuck, I really didn't understand that, please draw a picture and put it into the wiki. Then just send me that on, Quokka channel on Discord or via Twitter or however you might get a hold of me. Anyway, that's the general overview, and now let's dive into the code. So don't you hate it when some moron teacher just drones on and on about something, doesn't have a helpful picture and hopes that you understand it or expects that you understand it, kind of like I just did? Yeah, I hate that also. So my apologies, but let's move on and let's look at the code. The first piece of code is this thing that we run is called quokka worker. Remember, when you do this run workers, or if you do run all, it calls run workers, and it is going to run workers/quokka worker. Remember, this path is different than it was before because I moved workers out from underneath quokka there, and it's underneath the big quokka. So quokka worker, what does it do? Well, as you can see, here's a hint. We're going to actually be using this worker thread that I mentioned before, so you know that. The first thing that we do is we look and see, hey, are we running as root? And if we're not, then we exit. So you need to be doing that when you run it. The next thing we do is we're going to parse all of the arguments that are going to be passed in. So these arguments are going to be passed into us, and we are going to parse them. As you can see, if you see -q or --quokka, that's going to be the quokka's hostname or IP. That's what we're communicating with. We're going to need to know the worker type. So is this a port scan or packet capture or traceroute? We want to know the connection type. So are we doing RabbitMQ, or are we expected to go out and get our commands using HTTP? We have this virtual idea of a serial number that I haven't really fully implemented, but for security, setting things up so that there needs to be a matching serial number is something that can help. And then the heartbeat. In other words, how often is the worker going to communicate with the quokka server to let it know that it's alive? So that's what -h is. So if we were to look here, here's the heartbeat. So this is going to be the heartbeat that we're passing in. This right here, we're specifying what is the type of worker. Here we're saying what is the quokka server. In this situation, it's always localhost. What's the serial number, and what's our method of communication? So those are the things that we pass in. Once we have those things, for no particular reason, I set them to local variables. I could have just dereferenced args.quokka when I use them later on, but I decided to set them into my own variables. And now I go through and do a little bit of checking, nothing super extensive or anything, but I do make sure that I passed in a supported type of worker. and a supported connection type. And the heartbeat has to be something that is a number. And if I have that, all I do is I print everything out, and then this is it. This is all Quokka Worker does. All the hard work is done elsewhere. I create this thread. So we're going to look at worker thread in a minute, and then I start the thread. Now there are multiple ways to do threading in Python. You don't even have to do threading. You can do multiprocessing, and there's other mechanisms that you can use as well. I am creating this thing called worker thread. I'm going to dive down into it right now, and you can see that I'm inheriting from the Python thread class. And so basically this is a thread type of object that I'm defining here in my class definition. Now we haven't gone a whole lot into, I like to have a space there, into constructors, but just know that when I create an instance of this particular thing, so when I create a worker, I am going to call into this method. Remember, a method is just a function within a class. I'm going to call into it, passing in all of this relevant information. So this is the information that we got from the command line. Remember, from up here, we got that information off of the arguments, and now we're passing these in. Remember also, what do we call this? We were passing these by keywords, so they can be in any order because I've specified the keyword. So going back to my worker thread, I have this Quokka server, I have the worker type, I have the connection type, serial number, and heartbeat. I'm expecting to get all of those. There's no default values, and I'm going to be setting these values appropriately in this object. So in object-oriented stuff, I'm not going to spend a whole lot of time in Python 52 weeks. Python, I'll be going into objects in more detail, but just understand that when you create an object from a class, then it has its own data. And the way that you reference its own data is self dot whatever. So I need to do self dot for all of these different items. Now run is what's going to get called when we start our worker thread. So this thread is going to get started. Remember over here, I called into start, and so that is going to cause my thread to get started. Now let's look here and see what's in here, because there's a fair amount going on. One thing that's going on is this thing. This is what happens when we start up. We're going to look at this in just a minute. The next thing that you see here is there is a function which we call a method inside. This is heartbeat. Heartbeat is what we are going to call to cause us to send I'm alive messages to the Quokka server. That is what allows us to see in my Quokka when I go to workers. That is what's going to tell us the status, that we're okay. It will be the last heard value here, CPU and memory, and then we also pass along response time. So that is the information that our heartbeat is going to do. And I'm not going to go, we're just looking at an overview of this. So this is the heartbeat. This right here, start receiving, is if we are doing RabbitMQ, then we are going to call this function, and in this code right here, we are going to be setting up the queue that we're going to be listening to, setting up the connection, the channel, the queue, and then we are going to consume messages from that particular queue. Now, I don't have time to go into the details of RabbitMQ. I suspect that in 52 weeks of Python, I will be doing that. You can look up examples online, but if I'm doing RabbitMQ, then I'm going to be consuming messages, as many messages as get sent. I will consume them, and every time I get a message, I'm going to call this function, receive capture request. That is a function that I defined. If you have an eagle eye, then you know, oh, there it is right there. This is what I'm going to do. So for every message that I get, I'm going to print out something that says, "Up, I received a message." I am going to get the actual information that is going to tell me what I'm supposed to be doing. And then I'm going to process the command. And I'm going to process this command appropriate to the type of worker that I am. And here, down here you can see process command. Process command is going to say that if I wasn't given a Quokka server to use, I'm going to assume that it's localhost. Otherwise, I'm setting my worker info, my Quokka to the value that I was passed via this worker info. And then what I'm going to do is this, and reference back in your mind to what I was talking about with respect to these things over here. Capture thread, port scan thread, and trace route thread. This is only getting invoked, this process command, when somebody tells me, hey, I need you to do this. That could be, hey, I need you to do this packet capture. Hey, I need you to do this port scan. Hey, I need you to do this trace route. And going all the way back here, when somebody clicks on packet capture, then like we did before, and we go here and we specify start capture, then this is what is going to send a message. In fact, you can see down here, I have my worker running on my own system. I'm capturing packets right here. So my worker received the initial message. Let's see if I can go up to the top to where I got the message. I may have lost it all already. Yeah, I think I probably did. We can look at this at another point in time because I'm getting too many packet captures. It's filling up my buffer here. But I'm listening for the initial message, and then I am going to launch the actual thing that is doing the gathering. So it will be, in this situation, it was capture thread. I started a thread to do packet capture. If I was going to be doing port scan, so let's go over here, and I have all of my workers running right here, so it's going to be busy. We're not going to be able to see it until the port scan is done, until the packet capture is done, and that takes 5 minutes. But if I was to go here to hosts, and I was to say do a port scan on my Google Home device, then it looks like it's slowed down. Maybe we will get lucky here. So what I'm going to do is I'm going to move this over here, and I'm going to do start my scan. And if I look here, I can see that I got my message, my port scan worker. I got a message, and my port scan thread I started. So I started my thread, and then I started my port scan with this information. And then I ended up, here's the worker printing out the port scan data, and that's the data that I will end up sending. So I do port scan thread actually sends the data, and this is the JSON data that I will actually send, and this is my message that says I sent the port scan, and the result was 200. So let's go back to our code. I got kind of interested in that, but here when I received a message, remember my worker thread is listening for messages. If I received a port scan request, then I created a port scan thread, and I began to go do the port scan. So now let's dive into these specific thread objects. Okay, so before we dive into capture, port scan thread, and trace route thread, I want to reiterate what I said earlier. Worker thread, the nature of worker thread is entirely different than the nature of trace route, port scan, and capture thread. Worker thread gets created and lives for the entire existence of the worker living and doing stuff. Trace route and port scan and capture threads are transient. They get launched when there's a need to do a particular task, packet capture, port scan, trace route, and then they go away, all right? So just be aware of that. I don't want you to get the mistaken impression that trace route inherits from worker. In fact, if we were to look, we can see that worker here inherits from thread, and port scan, just as an example, also inherits from thread. So they're not These guys are not inheriting from the worker thread, okay? Just want to make sure that everybody is on the same page with respect to that item. All right, so I'm noticing that this is already going pretty long, and so what I'm going to try to do is give you a reasonably high-level view of capture thread, port scan thread, and traceroute thread, showing you the similarities. Now remember, these are transient. They get created when there is a need to do a capture or a port scan or a traceroute, and then they go away, all right? So they're short-lived threads. Now let's look at what's going on in them, and this will perhaps give you an idea. My packet capture thread, here's something that probably tells you how am I doing packet capture. Oh, well, we're using scapy and we're doing sniff in order to do packet capture. And sure enough, when we look down at the bottom here, you're going to see that, yep, sure enough, we're doing sniff. Now over here for port scan, you can see, whoops, here we're using nmap. And so we're using nmap to do our port scans. And if you were to think, okay, well, down here, we're probably going to do, yep, nmap port scanner, and then we do a scan. And at that point, we have the scan output. All right, that's pretty straightforward. Both of these were in the run method. And let's look at traceroute thread. Traceroute, what have we got here up? Well, we've got scapy again. We've got some more scapy stuff. Here's my traceroute. And if I were to scroll down to the bottom, again, I have a run method. And in my run method, what am I doing? Well, I'm actually doing traceroute. So here you see I'm doing traceroute. And at that point in time, in all of these situations, with the traceroute, I'm doing it once and getting the output. And then I'm going to end up processing the output, which will allow me to send it after I've processed it. With the scan, after I'm done with the scan, I'm going to process the scan, which will have me actually doing something with the scan and then sending it back to the Quokka server. Sniff is a little bit different. When I'm packet sniffing, this is not a one-time, one instance thing. It's something that's I'm going to set up and it's going to go on. You can see my timeout. I said earlier that it was going to be 5 minutes. I think I continue to do it for up to 3 minutes, as you can see, and I call process packet. So every time I receive a packet, I'm going to do something and I'm going to send this capture back to the Quokka server. Over here in my port scan, let me see if I can make it a little bit bigger. In my port scan, process scan, what am I going to do? Well, I have the data that I need, so I'm just basically going to send this again. This is sending the port scan, so it's going to do an HTTP to send the port scan. And over here in my traceroute, what am I doing here? Well, I just basically, I have to do some manipulation of the graph data that I got. So I need to use functions that are available in scapy in order to change the graph into something that is going to be base 64 so I can send it across the wire. Once I've done that, once I have it in the form of bytes, then I can do this thing right here. So these three things that are highlighted should look fairly familiar. In all these situations, I'm just going to end up calling in to my request library, which is what I use to do HTTP requests, and I send data back to the Quokka server. One of the differences here, after I'm done with this, I'm done totally, so my thread will exit. Over here, once I'm done, when I'm doing the port scan, I will end up exiting. And over here, I'm going to continue sniffing. So I'm sending a packet, and then the next packet I get, I'll send that. And the next packet I get that I've sniffed, I will send that. You may say, well, isn't that inefficient? Might I want to bulk them up? And the answer is, yeah, perhaps I could do that, but things get more complicated when you do that. If you're going to bulk things up, then you need to have a timeout so that if you don't wait forever, the timeliness of the packets arriving, if I wait too long to get a full set of packets that I'm going to send, then it delays the user interface, etc., etc. So I decided to choose the easy route. and just send one packet at a time, and that's why I'm sending just this one packet at a time. So this is an overview of these three different Python threads, the traceroute and port scan and capture. They live for a short period of time, do what they're intended to do, and then they go away. And the worker thread, as we mentioned, is the thing that lives forever and does the heartbeat and provides other information and listens for messages or receives commands in order to launch off these threads. That's the basic way that remote workers work. Hopefully that was at least a little bit understandable for you guys, and that you have a better idea of all the different pieces that go into making remote workers actually do their work. Okay, so let's talk about what we talked about in this session. And just FYI, I'm thinking about doing another session where we dive a little bit deeper into what each of the workers do, how the data gets stored in the database, etc. So if you have preferences on that or thoughts on that, feel free to let me know. So what do we talk about? We talked about what remote workers were and did. This is an example of a port scan. We also do packet capture as well as trace routes. So those are the things that the remote workers do. This is the general architecture of remote workers, where we get information about a request to be acted on by RabbitMQ. Alternatively, we can go get the commands via HTTP when we're doing the heartbeat. When the worker is done, the worker ends up sending the result of the port scan or capture or traceroute to the REST API of Quokka, and it gets stored in the database to be returned to the user. We looked a little bit at the code. We understood about Quokka worker being the highest level where things get passed to it. The run workers here, we see all the parameters that get passed to it. It starts a worker thread, and this worker thread is going to be responsible for heartbeat and for listening for messages or commands that are going to come in. So that is the worker thread piece that we see here. And after the worker thread, when requests do come in, then we go out and we start up a capture thread or a port scan thread or a traceroute thread, which are transient and perform their duties, send the results back to the Quokka server, and then go away. So that's what we do at a very high level. Hopefully that makes a little bit of sense for those of you that kind of understand what's going on. Then this will be a decent springboard into looking at the code more deeply. For those of you that are more intermediate or maybe even beginner, hopefully this gives you a little bit of an idea how you can build things using messaging and threads and REST APIs, etc., to accomplish some pretty cool things like we do in Quokka. That's it. Hopefully it's been helpful, and thanks for listening.